Okay. Good afternoon and welcome again to the week 6 problem solving session for this NPTEL course, Transition Metal Organometallic from Principle to Application. So in this course we have already completed, that is half of this course, that is the week 6, a total of 12 week course. So after completing the 12 weeks, let me briefly summarize the course, as I am waiting for the participants to join as usual. So after that I will start discussing the today's with questions, with the sample questions with the answers, and at the end I will discuss some important reactions or important topic which is covered in or discussed in this week. So in this course we have started with the different ligand system, that is the transition metal bound to different ligand. First we have started with the transition metal alkynyl complexes, that is the transition metal attached to a carbon atom where the carbon is sp3 hybridized. After that we have started our discussion in that prospect, the C H activation followed by the CH activation and CC activation followed by the CF activation. We have also seen that CF bond is very strong bond in organic molecule, and that's why there are very difficult to active. Some approach is that formation of the radical and then the active of CC bond. So we have seen that, and after that we completed our discussion with the transition metal alkyl complexes, that is the transition metal attached to a carbon atom where the carbon is sp3 hybridized. So after that we move to the another ligand system, that is the transition metal attached to a carbon atom where carbon is sp2 and sp3 hybridized. A sp2 and sp hybridized, that is the transition metal alkyne complexes and transition metal alkene complexes, where alkene complexes means to that transition metal bonded to the carbon atom where carbon is doubly bonded sp2, and after that it is a triply bonded carbon atom whereas carbon atom is sp hybridized. So with that we have started our discussion and see that when alkene or alkyne is generally seems to that an electron rich center, but as soon as it is bind to a transition metal or metal center it become electron deficient. We have also seen that the polarity reversal, that is the unpolar nature, is also observed for the alkyne complexes. And at the end of this week we have started our discussion with that very important system, that is the transition metal alkyne complex, transition metal alkene complexes, that is the transition metal carbene complexes. So with that, as we'll wait for another 2 minutes if to see if anybody joins, otherwise we'll start this session. We start this session. After that we will start the session as usual, like followed question answer discussion followed by the discussion of some points regarding that topic which has been covered in this week. Let me wait for 2 minutes. Okay, so as nobody is there till now, so I will continue this session uh, as problem solving or discussion session, and after that we will upload the video as usual in the YouTube, and we will get the link for that. So if whoever watching this video from the YouTube, I will ask you to join from the online, that is live, from online live, that is uh, every Sunday from 4 to 6 to get your doubt cleared and to get that answer for the following questions. Okay, so let's start with that first question. Okay, so if you have so as nobody is there, so if you have any doubt in this portal, not in the portal question, so in my question answer series, so that is that YouTube link videos which are uploading, or the link which are uploading in the drive. Good afternoon. If you have any doubt, you can ask me, and otherwise I will start the session by solving that problem with the answer. If you have any doubt, you can ask me. You can unmute your mic and you can ask me, or you can post your questions in the chat box also. Okay, then if not, then let's start the session. So week 6 we have completed our CC activation followed by the CF activation, and we move to our second transition metal carbonyl ligand system, that is the transition metal alkene system or alkyne system. So within that context, our first question is, the bimetallic complexes with linear C triple bond C N bridges as spacer groups. C triple bond C bridges as spacer groups relevant in the field of. So here it says that bimetallic complexes with bridges as a spacer groups are relevant in the field of. We have seen the end of the week 6 content, that is the week lecture number 30, the series of bimetallic complexes where C triple bond C act as a spacer or we can say that it is act as a linker in different system. So the role of this is now in electronics. So it is an insulating material, it is a gas storage material, it is a super lightweight material, or it is a conducting material. Which one will be right answer? Okay, so these pressure groups are with the acetylene moiety, that is the alkyne moiety, better to say, alkyne moiety is act as a very good conducting material in the electronic semiconductor device, because you can see that here these all the double boron pairs are conjugated, conjugated. So these can transfer the electron from one alkyne system to another alkyne system to this two pi electron cloud, through the pi electron cloud, conjugated pi electron cloud. So these compounds act as a very good conducting material. I think the reason and the answer is clear. As the acetylene moiety or the alkyne moiety contains C triple bond C, that is the high pi electron density between the two carbon atom, and these are all conjugated. So because of this conjugation, electron can freely move around the linear system and it gives a better conducting material. Okay, so next question is, among organometallic complexes that are explosive is or are? So among organometallic complexes that are explosive, so it is MCO, that is metal carbonyl complexes, it is metal alkyl complexes, that is MR, it is metal acetylide complexes, it is metal aryl complexes. So we have seen many metal carbonyls which are stable even at the room temperature. So metal alkyl complexes are also stable, and metal aryl complexes or metal alkyl complexes are stable and they are not explosive. We are using in these complexes in the Grignard reagent. Grignard reagent. So RMGX. So that means these complexes are not explosive. So remaining one is metal acetylide complexes. So sometimes the metal acetylide complexes are made as explosive. So metal acetylide complexes will be the right answer for this question. So among the following transition metal complexes, only metal acetylide complexes are generally explosive in nature. Not all metal acetylide complexes. So few metal acetylide complexes are explosive in nature. Next question is the carbene carbon atom in the shock type carbene complex is. So carbene carbon atom, so I have already mentioned that we have completed the sigma alkyl complexes. Now we move to a system where metal is bound to a carbon atom which is sp2 hybridized. That means metal is bound to C double bond C. Now metal bind to a carbon atom that like this. So depending on the substituent on this, it is R, it is X or H or R. So this is called the carbene. So when this R and R, these two are same, that means so R and R both either alkyl group or hydrogen, or what can be other possibility? It can be one alkyl group and one hetero atom. So when these two are the possible condition for this, the substituent on this carbon. So based on this substituent, we name these two system as Fischer carbene. So when this is heteroatom, we called it as a Fischer carbene. And when this is both are alkyl or hydrogen, we called it as a shock type carbene. So now for the shock type carbene, we want to know whether it is triplet or sp2 hybridized. So the shock type carbene is so these will have triplet state and hybridization will be sp2. So that means shock type carbene is triplet carbene and has an hybridization of sp2. So shock type carbene representation will be metal double bond C, when this will be R and another will be R or H. That means both have the alkyl group. That means carbon in attached to the either carbon atom or either hydrogen. So this is called the shock type carbene. Is one of the substituent is heteroatom, then we called it as a Fischer type carbene. Okay, so option number C will be the right answer for this question. So next,
No, sir, sorry, sir. Like I joined a bit late. I was dozing off. That's why. Sir, could you please explain more about this triplet carbene? Like triplet carbene in the sense like there'll be metal double bonded with metal atom because of the back bonding. Am I right?
yes, triplet
Okay,
carbene
sir.
when the carbene, so so when the carbene is, that is the electron, that is the two lone pairs. So this is the C. So if you have two lone pair on the carbene atom, now if these two lone pair resides in two different orbital, then we call them as a triplet carbene. If this,
Like electrons are in two separate orbitals, we call it triplet.
yes, if they are
Okay.
in a same orbital like this and this, then
Singlet
we
carbene.
call it a
Singlet carbene.
singlet carbene. So here for the shock type of carbene it becomes triplet and
Hmm.
hybridization is sp2.
sp2. But sir, in the case of singlet carbene, it forms only metal single bond carbon. Am I right?
No, no.
Hello.
When carbene is attached to, it is always doubly bonded to carbene. See,
Okay.
that is not the double bond or single bond. When it is carbene, it is always doubly bond. So
Okay.
the
Double bonded.
spin state is different just. That
Okay,
is
sir.
transition metal. We have already discussing the transition metal, alkene, alkene complex,
Yes, sir.
alkene complex.
Yes, sir. Okay.
The next question is the predict the product of the reaction. So the first two question you take it. So is this should I explain to you or you will check it later?
No, so you can explain, sir. Second one you can explain.
Okay. So and start, that is the bimetallic complexes with linear C triple bond C bridges as special groups. So this is the C triple bond C. So we have seen a series of bimetallic complexes with gold and other metal at the lecture number 30. That is the last lecture of this week. So you can see that when these two systems are like this is linear, so there is all pi electron cloud 2 pi systems, all are 2 pi pi orbital is there, px and py and pz. So these 2 pi orbital and this is all are in conjugation. So because of this conjugation, what will happen? So these electron can move throughout the bond. That's why this type, when the compound have these alkynes groups as a spacer, so these act as a good conductor of electricity because it can easily conduct the electron because of the resonance. So they
Due to
have,
delocalization of pi electrons.
so that's
Okay.
why the compound becomes highly conducting material.
Conducting. Hmm.
The next question is, among the organometallic compound which are complex are explosive. So that is the metal carbonyl MCO, that is the metal alkyl, that is the MR, metal acetylite MCCR,
Triple one CR.
and metal aryl
AR.
MAR. So here you can see we already know that Grignard reagent, that is the RMgX. So this is a
Hmm.
kind of, you can say this or you can have this, and Grignard reagent are non explosive.
Non-explosive.
So option A, B and D is always not possible. Okay,
Hmm.
and
Okay, sir.
some metal carbonyl are there, that is the, we have already discussed Fe2CO9 and FeCO5. So these complexes are exist without any decomposition. So for
Yes, sir.
that reason, so metal carbonyls are also not explosive. The
Yes, sir.
remaining one is the acetylite. So acetylite complexes, not all acetylite, some metal acetylite complexes are explosive in nature. Okay,
Yes, sir.
with that,
Yeah.
with by helping of this, eliminating the option, you can get that correct answer for your question. 3 I have already discussed. So question 4 is predict the product of the reaction. So this is a very important reaction. Why? To predict the product of the reaction. So this is C2H2, that is HCCH and methyl
CH.
iodide.
Yes, sir. Can it be option D? Yeah.
It should be, it may be option D, but as I said that this reaction is important, so the
Yeah.
product of this reaction will be option number B, because this compound is very important. You can see that osmium is bound to a ring. So if I draw this compound, so this is our normal aromatic benzene ring, so which is, you can say that, organic molecule,
Okay, sir.
organic molecule. But here what happens, this compound is formed and this is OS, osmium. This compound is somehow like this. So here, and all other substituents remain the same. So here you
Okay.
can say that this is an inorganic analogous of benzene. So it is a metallocycle is formed using the osmium as a metal. So here this is also aromatic, and here also the all carbon-carbon bond distance remain equal, and the NMR shift twice, it is also appear in the downfield position.
Due to an anisotropic effect.
So the option number B will be the correct answer for this reaction. So this reaction is very important reaction, and it may appear in your exam also.
That is like three molecules of acetylene, right? Three molecules of ethine that's used to form benzene with osmium.
Yes.
Okay, sir. Fine, sir. Fine.
Okay. The next question is, the HC111C minus ligand is not isoelectronic. not isoelectronic with.
Like first you have to calculate the total number of electrons that is present in HC triple one C minus, isn't it?
Yes, yes.
Yes, sir.
So let's calculate this, and then after that we will calculate the question one. So
Yeah,
CO.
fine.
So CO what will be? Carbon has 12
12,
plus oxygen 16. So
16,
total equal to,
28.
then Cp minus. So Cp is,
Like cyclopentadienyl anion.
so how many electron?
1, 5. Like there are 5 carbons, so 12 5 is 60.
Then
Then plus hydrogens has to be taken into account. 4 hydrogens.
huh,
Plus 1 negative charge. Plus 1.
yes. So then for the cyanide, Cn minus,
Cyanide. 12 plus 14 plus 1.
that is equals to,
27.
and then nitrogen.
28.
So you can see, and what is that for this one?
12 plus 12 plus 1 plus 1. 26. Is not isotonic, isoelectric with. So it should be option B maybe. 60 plus and 4 plus.
Yeah, option B.
Yes, sir.
Sir, in case of isoelectronic species, only valence electron can be counted?
Yes, not the overall electron. Only the valence electron available. That I am going to tell you.
Okay, so I also had a doubt in this one, so that's why.
Can you please explain valence electron?
In case of first our problem, there are 10 valence electron, 4 valence from each carbon and 1 from hydrogen and 1 from anion.
Hmm.
So this H C triple bond C minus. They are saying this one is 4 and this one is 4, this one is 1 and then 1. Okay?
Yes,
Give
sir.
you 10. And then what? How many for the CO?
It will also become 10 for carbons 4 and oxygen 6.
So carbon has 4 valence electron plus oxygen has 6. That will become to 10. Then for the nitrogen has
5 plus 5.
5, means
5 plus 5.
2s2 3p1, right?
2s to 3,
3p3.
2s to 3p3. Yes.
3p3, sir. 3p3, yeah.
So 5 plus 5. equal to 10. For Cn, carbon has 2s2 2p
2.
To be 2.
equals to 4, and nitrogen is same, plus
Same.
5.
5,
5
and then plus 1 equals
plus
to
1. 10.
10. And for the CP ring, so these all are giving 10, so there is no option remain. So but how many for the CP ring?
Sir, it might be 26. As for each carbon has 4 and one hydrogen has 1, and for
Yes,
anionic then 1.
yes. So that's why you get that isoelectronic species is CP,
26.
not in the. Is it clear?
Yes, sir. Clear.
Yes, sir. Yes, sir.
Okay. So when it says that total valence electron, then only we will add the total number of electron for this. But for the isoelectronic system, isoelectronic means the electron take parts in the reactions only, not the core electrons. Okay. The next question is predict the product of the reaction. It is also from the last lecture. What will be the product?
Sir, which one?
Question number 6. It is a tungsten WCO6 tungsten hexacarbonyl.
Actually, sir, a slide is not yet moved. For me, it's showing slide number 6 only.
Has 6. We are talking about.
No, sir, I'm saying slide number 6. Ah, okay. Now it is open. Okay, sir.
Okay.
Yes, sir. Okay, create a combination WC6 and
Okay. 6. Question number 6.
yes, sir. Yeah. Yes, sir.
In presence of ether as a solvent. Okay. So in presence of a lithium R, that is an alkyl lithium medium, so what will happen? It will attack to one of the carbonyl group. Okay. So
Yes,
W
sir.
C double bond O, we have R minus, so this will attack to this and this will open.
Open up.
Now what will be the answer?
Can it be answered D, sir?
Yes.
Okay.
So
Okay, sir.
the and so this will be
Okay.
like this. So in this medium, so answer D is the right answer. So in this medium, if you add another reagent like with the same Me3O, BF4, so then what will happen? This reagent has a special reagent. because in the question it may be asked LIR, after that they will add this reagent and ask for the final product.
Okay, sir.
So this will be O minus Li plus. So this reaction is, so trimethyl Me3, O is for oxonium, F4 tetrafluoro, and B boron. So this is trimethyl oxonium tetrafluoro
Boron.
borate. Okay.
Yes, sir.
So these reagent act as a alkylating agent. Especially you can say this methyl group is there, so we call it as a methylating agent.
Okay, sir.
So what will happen? It will give the methyl plus generate, and this O minus will be converted to OMe, which will be the final product, because reaction will not stop at this stage. This is an intermediate when you add
Okay, sir.
LIR and ether. So in presence of this reagent, it will undergo the methylation and it will generate a transition metal carbene. Which type of carbene it is? Fisher or Shaw?
Fisher carbene.
Why?
So because here there is O minus O oxygen is there, so therefore because since it is present, since there is presence of heteroatom, so it's Fisher carbene.
Yeah. So this is a Fisher
Okay.
type of carbene. Okay.
Okay. Next, sir, like if you introduce Me3OOBF4, right? So what happens is OLA converts to OMe, the product D.
Yes. That will
Okay,
convert
sir.
to OMe. Just it is an alkylating agent.
Okay, sir.
Sometimes we use methyl iodide also, which is also an alkylating agent. But compared to methyl iodide and Me3OBF4, Me3OBF4 is stronger alkylating agent compared to methyl iodide.
Okay.
Or
So actually
especially,
it will be Me3O plus BF4 minus. Am I
yes,
right? Okay, sir.
that is called the methyl oxonium borate.
Yes, sir.
Okay. The next question is, identify the one which is or are not a coordination mode of alkyne ligand. So that is the question, just from a theoretical question, or mode of binding.
Not a coordination mode of.
Sir, it may be C or D.
Yes, sir. Might be C or D.
Yeah. So the correct answer is option number C, because here you can see that one acetylene moiety is bound to the 4 metal atom, 4 metal center, and acetylene has a very short carbon-carbon distance. It is not possible to simultaneously binding with the 4 metal center. Okay, so option
Yes, sir.
number C is not a binding mode, is
Yes, sir.
not a binding mode for alkyne ligand. So here it may be sigma type binding, sigma pi, or coordination, but simultaneously to bind with the 4 metal center is not possible for the alkyne. Next is, identify the correct statements or statements. Identify. So it says that it's not L, it is larger, larger, Larger. Larger metal prefer to bind. Larger metal means you can assume that 4D 5D, 4D, 5D. So larger metals prefer to bind CO in a bridge mode or bridging mode. Option statement B, 18 valence electron rule explain the presence of an metal-metal bond in a metal carbonyl complex. Next, CO bridging may exist in dynamic equilibrium with its non-bridging mode. Antiferromagnetic coupling is not possible in a metal carbonyl in the case of paramagnetic complex. So when this type of question arises, so you can see that here there are four statements, and fourth statement is about the carbonyl compound, that's for sure, but it describes the different four property of carbonyl compound. Okay, so what will be
Yes,
the
sir.
correct statement about the metal carbonyl?
It will be option B, sir.
Next,
Sir, B is also correct, sir. B. Option B is also correct.
what about option C?
See, this dynamic equilibrium is non-bridging mode. Sir, option A is correct, right?
Its question is to identify the correct statement.
Yes, sir.
So which statement is correct?
Okay, sir. So B is one option, sir. Along with that,
Okay, so here you can say that a larger metal prefer to bind CO in a bridging mode. So I told this thing that first or second series, that when we have the metal in this, like ruthenium or osmium, their carbonyl complexes are cannot be bridging because the size of the orbital of osmium or ruthenium is so large that it cannot overlap with the orbital of carbon, that is the 2s and 2p orbital. That's why simultaneously with the two metal center, that's why the larger metal complex, larger metal center always prefer to bind with the carbonyl in the terminal fashion. The
yes, sir.
this question option number B is very interesting. It says that valence electron rule explain the presence of metal-metal bond in the carbonyl compound. So now this option may be right, may not be right, because we have seen an example Fe2 CO9. Okay, so last day I draw the structure also. So in this, if you go by a 18 electron rule, so it will have and rest of the 3 is, Okay, so now if you calculate the total electron count, that will be how many? So iron D8. Okay,
D8, sir. Yeah.
so 16 plus
Yes, sir.
1 2 3 4 5 6 7 8 9 plus 9 into 2 18.
18.
So then total electron is
34.
34. So but we always assume that complex obey the 18 electron rule. So that means
Yes, sir.
it is 36 electron. So what is the
Yes, sir.
36 electron possible? That means there is a one metal
One
bond.
metal bond, sir.
Yes. So but actually when we got the structure of these complexes, crystal structure, we see that there is no metal bond.
Yeah.
Okay, but most of the books you will see that to satisfy the 18 electron, or previously or old concept was that the FeFe contain a one metal bond, but actually in this complex there is no metal bond. So this is an exceptional a case of 18 electron rule where it cannot explain the metal bond is present or not. So that is something above the 18 electron rule, we can say. Okay. So but if the question says that let's assume the complex have the satisfy 18 electron species, now calculate the number of metal bond and number of bridging CO and terminal CO, we definitely write it contain one metal bond and 3 bridging CO and 6 terminal CO. Okay, so you can say option B is correct, but actually 18 electron rule is not the ultimate rule to explain the metal carbonyl metal bond in carbonyl complexes. Now option C is CO bridging may exist in dynamic equilibrium with non-bridging mode. What it can be? Like if you have a manganese complex. So in here Mn, like similarly Mn2 CO10, like similar kind of complexes, when complex exists in solid state. Solid state means that is a frozen structure. So when the molecule or the compound is in solid state, the distance between atom or their entropy is less. So in that case, this CO can bridge between the two metal center. But when it goes to the solution, because of the increasing entropy, the bridge breaks and it becomes the terminal. So CO bridging can be terminal or it can be bridging also, or it may have an equilibrium. That is it's called the dynamic equilibrium. That means at some instant it is bridging or at some instant it is in terminal. So it's the in between
Terminal.
bridging and terminal. So in this thing is called the dynamic equilibrium. So this is also possible for CO bridging case. So if you increase the temperature, maybe the bridge will break and it will become as a terminal CO. Okay,
Yes, sir.
so this is a correct statement for this.
Okay, sir.
Another thing that antiferromagnetic coupling is not possible. It says not possible in a metal carbonyl in case of a paramagnetic complex. So is it possible? Yes, it is possible, because if you have a paramagnetic species, let's say you have one unpaired electron here, one metal center, let's say iron, and you have another metal center like another iron having another unpaired electron. So that unpaired electron may lower down the spin because of this FeFe bonding or through bond interaction. So because of this, what will happen? The magnetic property of this compound will be less because of the antiferromagnetic, it's called the antiferromagnetic coupling. Compound itself, if you consider by electron count wise, it is ferromagnetic because of having unpaired electron, but because of the through bond interaction or orbital overlap, so and one unpaired electron from one metal center can go the opposite direction with respect to the other metal center, nearby metal center. So that's why it can be possible to go the antiferromagnetic coupling for these complexes. So it is says that not possible. Yes, it is possible. So this option is also not correct. So here only option C is correct, but you can say that 8 electron rule is also correct. Okay. The next is the correct order of new CO, that is new CO, stretching frequency. Stretching frequency is
Should it be option B?
Can I explain why option B?
So I would say like first terminal carbonyl is so which means terminal carbonyl means like metal is attached directly to carbonyl.
Yes.
So which means like that NMR spectrum.
Carbon. Yes.
Yes, sir. Then mu2 Cu means like CO is attached to like two metals. That's why mu2.
Is this?
Then mu3 Cu means carbon is attached to three metal atoms.
Now question is why it decreases from this to this.
Yes, sir. Next, I've heard like whenever a carbon is attached to metal with a single bond, which means like the NMR spectrum will be like stretching frequency like increases. But as it tends to bridge with as it tends to go under bridging, like say to like bridging with two metals or three metals, the stretching frequency decreases. Hello.
Yeah.
Yes, sir.
Okay. So terminal CO will have the more stretching frequency compared to the mu2 CO and the mu3
Mu3
CO. Okay.
Yes, sir. Like it can also be possible because the back bonding might decrease, like as you go from terminal to bridging. Can we say like that, sir?
When we are talking about the new CO, we are not talking about the frequency of this bond. We are talking about the frequency of this bond.
Okay.
Right?
Yes, sir.
Is this correct?
Yes, sir.
So what will happen? For the terminal CO, as number of metal here increases, okay, so that
Yes, sir.
will increase the possibility of more metal to ligand pi back donation. So what will
Sir,
happen?
what increases the pi donation? Like, can you repeat once again?
If here you have one metal center,
Yes, sir. Okay.
if you increase the number of metal, so
Yeah.
every metal is donating to the carbon in pi back donation.
Yes, sir.
So that means carbon will experience extra positive charge, extra negative charge, and then
Yes, sir.
extra negative charge will go to the pi star orbital.
Pi star orbital.
And
Yes,
if
sir.
extra go to the pi star orbital, that will decrease the bond order.
Yeah. Okay. Yes, sir.
And bond order decrease means stretching frequency decrease.
Yes, sir.
Okay.
That is bond length will increase. You are saying.
Yes.
Okay.
Because stretching frequency is directly proportional to the bond length, right?
Yes, sir.
Directly. So what is the yeah, what is the equation of stretching frequency?
Sir, that I am not aware about it.
So stretching frequency nu is directly proportional to k.
Okay.
K is bond
Force
strength,
constant. Force
force
constant.
constant k, and it is inversely proportional to
Mu.
mu. Mu is
Oh, okay, okay, sir. Okay.
mu is reduced mass.
Reduced mass. Okay, sir. Okay. I think that IR formula which we studied, right?
Yes, yes, IR formula.
Okay, sir. Okay, sir.
So here our mu is fixed because we are only talking about the CO.
Yes,
Only
sir.
changing is the force constant.
Yes, sir.
Force constant is directly proportional to your bond distance
Switching
or
to
bond
okay,
length.
bond distance. Bond length.
So
So also it is proportion to bond order also, right?
yes, bond
Okay.
distance means bond order increases.
Yes, sir.
Got it again, right? Okay.
Yes, sir.
So next question is, predict the product of the reaction. So this is a TM transition metal alkyne complex. When it reacts with this, what will happen?
So it should be option D.
So you see that with option C and D, only difference is this CaPH and Cn,
Yes, sir.
and that number of, no, not with option C, with option B, pH and Cn.
Okay, sir. Okay.
Okay, not so these two you definitely not happen.
Yes,
With
sir. It's not
B
possible.
and D, what will happen?
So I think D can happen.
How?
So like CN is like this more nucleophilic, so therefore so when it can attack on the alkyne such that the bond gets donated with the iron atom and then it can form a structure of D. That is
Yes,
my reason. Okay,
yes,
sir.
but here option B will be the correct answer,
But how?
because here this pH group act as a better nucleophile with respect to the Cn. That's why that product formation will be option number B, not the option D. So only difference is that I said one is the pH and another is the Cn.
CN.
Okay, so here the alkyne that which is there in the starting material, the alkyne we know that it generally act as a electron rich species, but as soon as is bind to the metal center it become electron deficient. So that means there is a change of polarity observed. So for
Yes,
this
sir.
complex also, so this will, the pH will react with this to get your product B as a, not the option. So cyanation will not happen here. Okay.
So you are saying phenyl is a better nucleophile than cyanide.
Here is reacts more nucleophilic compared to the CN.
Yes, sir.
That's why product B is forming, not product D. That's why this question is also very important question.
But sir, like here in this case, does it have any nucleophilicity order? Like in the upcoming videos which has been
No,
uploaded, is there any nucleophilicity order for that? Like pH is more than CN, like.
no, nothing. So this particular question, so for this particular reaction, option B, that is the pH will be substituted, not the CN.
Okay, sir. Like it is given in the lectures you are saying, like in the
Yes,
lecture it may be given why like there is a
yes.
nucleophilicity order.
Okay.
Okay, sir. Yeah. Lecture given by information is used in complete.
So I think this is the last question. Yes. So this is the last question. What is, so the metal to ligand pi back donation. This is 10. This should be 11. So the metal to ligand pi back donation is least in. So it says that
Option B.
metal to, which one?
Option B.
Option B. Why?
Like say it's a metal alchemy is like MC, right? So what happens is like when alkene can actually sigma can form a sigma bond with the metal atom. So it can like back donate.
Yes. So for the carbonyl, for the carbene and for the alkene, we have vacant pi star orbital where you can accept the back donated electron. For
Yes, sir.
but for the metal alkyl complexes, this is a sigma, we call sigma alkyl complex. It doesn't
Yes, sir.
have a pi star orbital, so it cannot accept the back donated electron from metal to ligand. So option B will be the right answer. Okay.
Okay, sir.
Okay then. Okay, so we have completed that week 6. Week 6 means half of the course, that is the 6th week, is over. Do you have any question or facing any issue with that? Any issue with the thing, with the question or?
Sir, like the lectures are over, you're saying? Like,
We are saying that it is a 12-week course, so
yes, sir.
6, that means half of the lecture is over, another half is
Okay, sir.
remaining.
Okay, sir. Okay.
So 50% course is already over.
Okay, sir.
Is there any specific question from this week?
Not yet, sir, but I'll go through it and then let you know. Maybe in the next session.
Okay.
Or sir, is it okay if I can connect you through email?
If you have any question from the if you have any doubt from the question which I am discussing here,
Okay,
okay,
sir.
so you can write to the email, in my email. See, that is, it is given in the slide. The starting of the slide it is given, and you are getting the link from that this email.
Okay, sir.
It is when you get that Google Drive link in the recorded sheet. All slides are uploaded there.
Yes, sir.
You are getting from the mail. So
Yes, sir. I'm getting several mails, sir, about it.
for this question, for this you will get a mail of the recording sheet. So in the recording sheet list, you will get a Google drive link where I am uploading these slides, and in the recording sheet there is a link for that each video session also.
Okay, sir.
So so if you have any particular question from these questions which I am discussing, so you can mail me with in this email address. Okay.
Yes, sir.
Or, uh, this is the one thing. Another thing is, if you have any particular question from the lecture videos or with your assignment problem that is uploaded in the portal,
Yes, sir.
so that you can ask to the discussion forum also.
Okay, sir.
Okay, so discussion
Yeah.
forum is open only for the portal assignment and lecture videos which is uploaded through week 1, week 2, week 3, week 4, like that.
Okay, sir.
And for my question, there this is not uploaded in the portal, I am doing is as a just for better understanding. So you can directly ask me in any Sunday,
Okay, sir.
or you can just through the mail you can directly ask me. It is, I recommend it is better you can just directly ask this question in this live interface. If I am able to answer, I will give you the answer as much detail possible, but if not, if I cannot get it, so I will just note it down, and in the next week, that is the next Sunday, I will discuss in detail.
Okay, sir.
Okay, is it clear?
Yes, sir. Clear.
Okay. 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 So here, when we are discussing the bonding with transition metal alkene complexes, so one thing always remember when this question was asked, so when it is alkyne, that means ene at the end, so then it's called the alkyne, that means carbon has a double bonded. But when the carbon atom is attached to the 3 bond, it's called the alkylide diene. So here you can see a very good example. So here you can see that metal is attached to a carbon double bonded, we called it vinyl.
Yes, sir.
But when this carbon it attached to a metal and another is doubly bonded, so we called it mu2 alkylide diene. So there is a difference. So
Yes, sir.
carbene is alkylidine, okay, and it is SM double bond C. But where it is 2 double bond, we called as alkylide diene. That means total number of 3 bond is attached to the carbon atom. That metal can be different. Here one metal, 2, one metal is 1. So this is 2 and this is 1. So that means it is total 3 bonds with the carbon atom to the metal. That's why it's called alkylidine. So this is a very confusing thing. So simply when we use the last 3 letter ENE, that means carbon is bound to the metal with the double bonded, and when is ine, the carbon is bonded to the metal with the 3 bond. Okay, and this mode of binding is also sometime asked in the question. So this is called the sigma pi mu 2 sigma pi alkynyl, because this bonding is alkyl group as well as the sigma bond as well as the pi bond forming, that is sidewise binding. So this is also are important. So this is called sigma pi bonding. Okay. Here is question: the nucleophilic addition to the cationic N2 alkyne complexes. So here I already discussed that this carbenic, that is the triple bond, when binding to the metal, the triple bond or double bond system, that is the alkene or alkyne, are called generally electron rich species.
Okay, sir.
But when it bind to the metal, it become electron deficient and it can undergo the nucleophilic addition reaction. So here also it's attached to the cationic eta 2 alkyne complexes, but here the nucleophile is pH, phenyl.
Yes, sir.
Okay. So this is an example where you can see that the sigma bonding, that is this carbon to iron is sigma bonding is happening, whereas this pi orbital is also participate in the sidewise bonding with the another iron. So this is phenyl group which will act as a sigma pi bridging ligand. So this is also an important reaction or example of sigma pi bridging. Oh, this one is another good example where we can prepare an eta 6 arene complexes, sandwich complexes from the eta 1. So here you can see eta 1 sigma complexes, that is C6H5 whole thrice chromium THF3 is converting to chromiosine complexes with the 6 arene ring, eta 6 arene ring. So here the conversion from eta 1 to eta 6 happens. Okay,
Yes, sir.
so this is also another good example of forming this compound. Next is this square planar nickel platinum palladium platinum complexes of mesityl MR2 are kinetically stable. So why these complexes are kinetically stable? Because you can see that orthomethyl group. So here the methyl group is there in the ortho position like this, and this methyl group actually bend that or rotate that structure. So orthomethyl the aromatic ring to a conformation that facilitates the overlap with the platinum DXY and pi star and shields the metal positive charge from the axial atom. Is as all the aromatic ring rotates, so the possibility of attacking from this axial direction is prevents because of the restricted rotation of the ortho methyl groups. So the decomposition via is also blocked through the ortho metallation, because as the ortho position of the aromatic ring is all are substituted, so it cannot undergo the beta elimination reaction also. This is the way where you can provide the kinetic stability of this type of system.
Okay, sir.
And here this question, the C2H2 and methanol, we have already seen that osmobenzene are these osmobenzene are planar, it is aromatic like the normal benzene, and this compound has also equal CC bond length, and signal in the proton NMR is also appear in the downfield shift spectra like the aromatic benzene ring, and also this ring undergo this osmobenzene ring. This ring undergo the electrophilic or aromatic electrophilic substitution. So this is the, you can say, metallabenzene. So metallabenzene is on a kind of metallocycle. That's why this is a important reaction. Okay.
Okay, sir.
So next is yes, here you can see that the transition metal alkyne complexes. So alkyne complexes are highly explosive because it undergo the hydrolysis, and you can see that copper iodide, if you react with this potassium salt of acetylene, so this will give you the copper acetylide complex. Now what will happen, let's say temperature it says less than 45, so it will form a copper carbide and strong acetylene and Ki. So because of this acetylene, so which is the gas and burn in air, so So this complex, so this acetylide remove or release acetylene gas, which that's why they are become the that's why the metal halides are explosive in nature. And some acetylide are also stable. Let's say for gold and heavy metals, the acetylide may be stable. And the last is when the gold 3 react to in SO2, it become gold 3 bromide, and then acetylide react with this. So this is gold alkynyl complexes. So here you can see this N, because this system makes a polymer to this. This is also sigma and pi kind of bridging happening in a same molecule. And in the last lecture we have seen that the formation of palladium 2 acetylide complexes via oxidative addition reaction, and as well as some linear, I have already said in the first question of today's series, linear bimetallic complexes. So here these bimetallic complexes, because of the highly conjugated system, that dense pi electron cloud can conduct the electricity. That's why this compound may be used as electrical equipment, electrical conductors. And last we discussed the transition metal carbene complexes. That means two types of carbene is there, and Fischer type carbene and shock type carbene. So Fischer type carbene contain the heteroatom, whereas shock type carbene contain either hydrogen or carbon, or that is the alkyl group. Okay, and we have seen some of the reaction. Here you can see, so Me3O BF4. So this is a strong alkylating agent. We will alkylate this to give this corresponding carbene, which is a Fischer carbene synthesized by Fischer in 1964. Okay. Okay, so I think I completed all the lectures and the some 10 or 11 question from this week content. If you have any doubt, still now you can say, or it is better to have your doubt and get the cleared in this live session. Or if you have any doubt regarding the chemistry, that you can also ask. You can post your doubt in the chat box also.
No doubts, sir. We'll let you know if I have any doubts.
Okay.
Currently, I don't have any.
Okay then.
Also, sir, one more thing, like about it, getting net coaching. I'm actually doing it online.
Yeah, you told last night. So that for coaching, once you finished one topic or one chapter or one set of topics, try to solve the question, all the previous year question from that topic
sir.
So that try to solve the question from that topic as soon as you finish the topic. Then you will have an idea whether you understand the topic or not.
Yes, sir.
Also, it is not possible to answer all the question from a particular topic which you have read. But for the common
Yes, sir.
topic, let's say, for example, if we give a topic, let's say statistical mechanics. Is it a topic, na? In physical chemistry? Statistical
Statistical
thermodynamics.
thermodynamics. Yes, sir. Statistical thermodynamics.
Thermodynamics. So statistical
Yes, sir.
thermodynamics. So there will be so many questions from that.
Yes,
So,
sir.
so many. So is this topic is such a topic? Whatever you read, 3, 4, 5 books, you may not answer all the question. So don't don't be very nervous or serious about that if you don't answer all the question after reading such a topic. But if it
Okay.
is, let's say, on topic is chemical kinetics, so in the chemical kinetics it's also physical chemistry topic, so in that topic you should answer all the question.
Yes, sir.
Okay, let's say in organometallic, so organometallic I will suggest you should answer at least 90% question.
Yeah.
10% you may not answer, because as I said in the last question that there is a not a CN group will attack, it will attack by a pH group. So some questions are like there are some questions which are really exceptional from the common point, so that question you will not able to answer. So it is better to skip that question, because
Yes, sir.
some and it, from current perspective, as I also mentioned in the last told you in the last 2 3 lectures that you cannot skip any topic.
Hmm.
So it is better to have an idea of all the topic, general idea of all the topic, and questions in the exam only attempt which you are like 100% confident.
Yes, sir.
If you attempt the question 100% confident and you calculate that your marks is not crossing 100, then you can answer the question which you are 90% confident.
Okay, sir.
So that
Like,
is
sir, currently I'm preparing thermodynamics, sir. Like in physical chemistry, I guess thermodynamics and quantum chemistry, these portions come a lot. Whereas in the case of inorganic chemistry, like coordination chemistry and then organometallic chemistry portions come a lot.
yes.
Okay, sir.
So from thermodynamics also you should answer 95% question.
Yes, sir. Like
5%.
about like heat capacity, Carnot engine cycle, or about the
Yes.
reversible process, irreversible process. Okay, sir.
So this is the very common topic. So everybody expect that you answer all the questions regarding of
Yes,
that
sir.
difficulty level.
Yes,
Again,
sir.
so from the quantum chemistry, or I said the statistical thermodynamics, all question
Yes,
may
sir.
not be answerable, or sometime it is, or sometime you may require to remember some formula to answer
Yes,
questions
sir.
from the quantum mechanics. But
Yes, sir.
thermodynamics you should definitely answer all the question. All the
Okay,
question
sir.
means at least 95% question.
Okay, okay, sir.
Okay, so
Yes, sir.
when you just finished one topic, give a test or give solve the previous year question, so you will have an idea what kind of question is asking in the examination. And
Yes,
also
sir.
another thing that time is also important. So let's say you can solve a thermodynamics question sometime are very lengthy. So
Yes, sir.
so when you will get the right answer at the end, but let's say the question is taking 15-20 minutes to just to solve in one question, that is
Yes, sir.
not worthy. So you should skip that question at first moment, and if covered you read whole question paper, then you come back to that question. And I am not know that current situation of the net, but I think there is a color coding. You can color code that question as yellow, as green. So there will be, you can just come back and see the
Yes, sir.
Okay.
Okay, sir.
As
So
well
for
as
organic, I think it will be like reagents and then this reaction mechanism. Am I right?
huh. So organic, so mainly you should focus, completely finish all that chapter for
Hmm.
any two stream, like for inorganic, it may be organic, it may be physical. So in the two stream like organic, inorganic, physical, any two, you should finish all the topics. And the
Yes,
third
sir.
one, you should finish 50% topics which are easy. Then you
Yes,
can
sir.
answer, then you will get a good score, or at least you can clear the JRF cutoff. And in
Yes, sir.
another thing, that in CS and net, remember that rank doesn't matter. You just only need to clear the cutoff. If you clear the cutoff by 0.25 marks, that's also fine.
Okay, sir.
Okay, so rank doesn't matter in CS and net. So rank matter in GATE examination.
Okay, sir.
Okay, so when you are preparing for GATE, just remember about the rank, and when you are preparing for the CSIR net, you have to just clear the cutoff marks. So make
Yes,
sure
sir.
you answer correctly, confidently such question which give you the enough marks to clear the cutoff.
Yes, sir.
Any other doubt or question?
No, sir.
Sir, my doubt is that about the examination,
Huh.
that is, our coursework's examination will be held in October, no, sir?
Hmm.
So the nature of questions is as same as the assignments and today's practice, or the questions will be different?
No, as I said that the question which I am solving, it is, some questions are new and some questions are previous year question.
Okay, sir.
Okay, so the question which you are solving in the portal as an assignment, in
Yes,
exactly
sir.
the same pattern will be in your final exam also. There will be no change, and
Okay.
it will also a computer based test, so it is an MCQ or MSQ type question, but it is not
Okay, sir.
easy. So as I said, the reaction which I showed, so these types of reaction you have to just remember, otherwise you will end up with the wrong answer. So some reaction you cannot and attempt the question just by having a common knowledge of knowledge of reagents or this. So you particularly some reaction you have to remember it, otherwise you will not get qualify the cutoff. This course, NPTEL course I am talking about.
Yes, sir. Yes, sir.
Okay, exam pattern will be exactly the same, like the question I am discussing, or like the question which is in the portal.
Okay, sir.
Yes.
Thank you, sir.
What is the date of your exam?
23rd October, sir. It's tentative date now.
Yes. So this is transition metal, organometallic. 20. This is 20.
20, sir. 20 October.
27.
Yes, sir. Yes, sir.
27 of October.
Yes, sir.
Okay. This is the previous year. My course. exam registration end is 22nd. Okay. Okay. So already week 7 is released. So
Yes,
let's
sir.
see the week 7 assignment. My screen is not visible, right?
No, sir, no.
No, sir, it's not visible.
Okay. Now it's visible. Now it is visible.
Yes, sir. Yes, sir. Yes, sir.
Oh. So this is the portal assignment. I have not checked it. So see there is lots of question. Just the reactions they have asked. So if you don't, so these are all the reaction based question. There is no theory question in this assignment. So don't if you don't remember this reaction, you don't practice just by writing, you will not able to answer in the exam. Week 6 also, I think. My question is the combination of my question is a combination of, see this question, I told this reaction is important. So this question was asked in the already in the last week. So this is week 6. Yes, week 6 we are on talking about. This is also example of osmobenzene. Okay. So this there was this is a like, so most of the question we have discussed and you should able to answer this question, and these questions are all related to this. So as I so goal of this weekly interaction is to get an idea of what type of question can be asked and what has been asked. Okay, so you will have to finish this assignment, and also in the exam question will be like the same. So I think the theoretical question will be minimum and reaction type question will be maximum. Sometime I have seen one question saying how the following compound can be prepared by. So you have to know the this is the your product, so you have to answer the reactant of this. Okay, so this is maybe a MCQ type, it may be a MSQ. So reactant may be 1, maybe 2. You understand this, right? So the
Yes, sir.
Yes, sir.
so so this will be similar like your exam, nothing different. Okay, so when you read this thing, just practice all the reaction, mainly the reactions. So you write down all the
Yes, sir.
reactions in a notebook just by the
Hmm.
week wise, and just revise it. So I think if you remember that reactions, you will answer all the questions. Without writing you will not able to memorize this. So better advice is, when you read the slide, don't write the theory. The theory you can remember, but the reactions you have to take a note of it if you want to qualify the exam. Okay.
Yes,
Yes,
sir.
sir.
Okay then, see you in the next Sunday. So read or listen all the on the lecture, or read that book which I have in the portal. It is also there. You can see here if there is a book, you can download the book, English book. It says below the transcript point. So you can download that and also read that book, or you can also listen to the video lectures. Both are same. Okay
Yes,
then,
sir.
see you in the next Sunday.
Sure, sir.
Okay then.
Sure, sir. Thank you, sir.
Thank you, sir. Thank you very much for
Hmm.
today's session.
Okay, so just completed the week 6 series, and it was a very good interactive series. So I'll ask the other who are watching the videos from the YouTube, try to join in this session and get your doubt cleared and interact to get an idea of questions, topics which will be helpful to solve your assignment and which will be helpful for your final exam also. See you in the next Sunday, that is September 7. September 7 on the same time, 4 to 6. Thank you.